and non-ferrous materials. So for ferrous, we have iron, cast iron or gray cast iron, malleable iron, wrought iron, steel, steel alloys, and stainless steel. The other side, we have the aluminum, lead, zinc, chromium, monel, copper, bronze, and brass. We'll tackle some of them, not all of them, because we'll tackle only those which are more popular, more common in construction. Okay, so let's start with ferrous materials. The first material that we'll tackle is cast iron. Okay, cast iron melts at 1,200 degrees Celsius and is relatively brittle. Since it melts, you can actually mold it. So when steel was first discovered as a construction material, it was more of cast iron. If you remember in your history of architecture, um, during the Romantic period, there was a um, glass palace um, constructed before, and then most of it were made of wood, glass, of course, but the steel is cast iron, and then of course the wood, some wood. But the glass palace burned down. Okay, and you might wonder, okay, if wood is the only material combustible, so it should still be up, no? So some broken glass maybe, but then the cast iron during the fire also melted. Okay, so that's why everything went down. Um, a lot of the old buildings are like that, no? So cast iron, especially their columns, um, they're molded into ornate shapes, especially looking like classical columns. But then it's not very reliable when it comes to fire. So some applications, automotive parts, pipes, machineries, and other engineering parts, and decorative architectural elements. Now for pipes, cast iron pipe is very common before. Okay, so before the advent of the PVC pipes, so cast iron pipes were used for the waste system. Mild steel or malleable iron, these are malleable and easily moldable metal, and that's why they're normally used for construction, especially in gratings, stair components, and manhole covers. And they're also applied the same manner as cast iron. Okay. Here in the picture, you can see the deformed bars, which are used as reinforcement bars for concrete works. High carbon steel is highly resistant to corrosion, strong and tough. Um, the picture you show, so you see here is a cable. No? It's a high tension cable which is normally used for uh, like suspension structures, suspension bridges, or even for guy wires in posts, electrical posts. So they're really very strong. Although they can also be used for cookwares, no? But then they're used for springs, blades, coupling, crankshafts, and other things. Stainless steel is, I think, very popular. It contains about 18% chromium, 8% nickel, and 8% magnesium. It's used in many forms, but it's quite expensive, so it's not really popular for the usual common application like flashing, coping, and fascia. Wall panels, unless it's a really special construction, but the most popular use for stainless steel are handrails, fasteners, and hardware. Fasteners, when you require a fastener which does not easily corrode. For example, in the work in restoration, when we have to put back some stones into place in a wall, and then we need to fasten it using clips. So we made sure that the clip is something that does not easily corrode. So we use a stainless steel fastener. Okay, so we don't use the ordinary steel. So wrought iron. So I'm sure that you've seen a lot of applications of wrought iron, especially on very decorative, say, railways, or like what you see here in the picture. So the grills, they're soft. They're also corrosion and fatigue resistant, and then machinable, which means that you can bend it, you can shape it. Um, so wrought iron is normally used for fences and grills. That's the and various types of ornamental work. So that's the most popular use of wrought iron. For non-ferrous metals, the most common, of course, is aluminum. It's high purity aluminum. It's soft and ductile, highly corrosion resistant, although it's lacking in strength. Okay, so it can be a bit brittle sometimes or malleable. Um, So it can be used for roofing, sheet metals, sidings, and conduit. Lead, the picture you see here, I chose this because this is how I encountered lead most of the time. It's very, very malleable. It's almost like clay, but a little bit harder than clay. Um, I'm referring to like the Play-Doh, no? And it's used for waterproofing. So you melt it and then you apply it on the roof, and then when it hardens, it makes it impenetrable to water. It's also good for sound and vibration isolation and even radiation shielding from protection from the sun. But lead is toxic, as you can see here. Again, in history, if you have read about the town that was buried by Mount Vesuvius in Pompeii. So there was one theory that all the people there actually died even before they were buried by the volcano. It's because all their cookwares are made of lead, or at least covered in lead. So chances are they have died of lead poisoning. So lead is not something that you can use where your health might be in danger. No? You can't use it in cups or in plates, or especially use it as fork. Zinc. Um, on its own, zinc is not used in construction. They are normally mixed with other metals, part of an alloy, especially with uh, um, in galvanized iron sheets that are roofing, so they're zinc plated. Um, Most of these, for example, roofing, flashing, um, so galvanizing. So this is the most popular roofing now. It's because it's not expensive. And copper is also very, very popular before as a as pipes, no? Especially to carry hot water. So if you have a hot water system, normally copper pipes are used because they're good insulation of heat. So the heat does not easily turn cold within the inside the pipes. But copper pipes are very expensive, so that's why they came up with more inexpensive materials like well, plastic pipes like PVC pipes, which are for hot water and other uh, alternatives. No? It's also very, very um, conduct conducive for electrical wires. Most of our wires are made of copper. Okay, so they are good conductors of electricity. Now, brass is copper with zinc. Okay, as its principal alloying element. However, some types of brass alloys often are called bronze, even though they are not. So when a metal is identified as bronze, the alloy cannot contain zinc. or nickel. If it does, it probably is brass. So there is a difference between bronze and brass. So bronze does not contain zinc or nickel. So the medals, which are bronze, are like this. So brass is used in many applications, also in architecture for doors and windows, especially in hardwares. Um, you have a brass fitting, brass hinge, brass um, lock sets, then trims and grills and railings. They're also used in railings. Now, the problem with metals is that they can get corroded. So I have here three types of corrosion on metals. One is called galvanic action or corrosion, and this happens because of interaction with another metal. So the table you see here shows how much a metal reacts with another depending on the location of that metal in this table. For example, magnesium and zinc, so there will be a reaction, but since they are very near each other, so the reaction is very little and it may take time. But magnesium and the one at the very bottom, graphite or gold or platinum, so the reaction is fast um, and worse, no? In terms of condition. And then also the one that suffers more are the ones which are on top of the table. So um, graphite, gold, and platinum remains stable, but the magnesium will corrode. So for example, another example is if you have brass and then you put aluminum beside it, so aluminum will be the one that will corrode first. We also have what we call pitting. It's a corrosion that occurs when particles or bubbles of gas are deposited on a metal surface. So in construction, we have that waffle because there are air pockets or air bubbles inside the cement or the concrete. So it can also happen in metal. And then we have concentration cell corrosion, which is actually rust. Similar to galvanic corrosion, the difference is in electrolytes. So there is the corrosion is produced by differences in ion concentration, oxygen concentration, or foreign matters adhering to the surface. So the reaction is the same, except that the cause is different. So the cause for galvanic action is the combination with another metal, but here is the other causes other than that. Now, how do we fabricate metals? So there's a lot, and then there are terms that are very confusing. One is rolling, so it's very easy to imagine. The picture also shows it. So the metal goes through rollers, and then they are shaped accordingly. Extrusion. In this process, the metal is pushed under pressure through a die orifice, producing various complex shapes limited only by the size or capacity of the die. Die, if you're not familiar with it, is like a mold. Okay, so it's not that's die. Okay, this process is applicable to all metals except iron, because once you extrude iron, it breaks. Okay, so iron is not very malleable. Casting is so you melt the metal and then you put inside a mold, and then you have that. So cast iron, I mentioned before that you can shape it into anything. So that's the process involved, no, casting. So it's applicable to aluminum, copper, iron, steel, bronze, and other metals. However, surface quality and physical characteristics are affected by metal type, casting techniques, and the molten metal's temperature. Okay, so bronze medals, for example, are cast. so they're not carved. Drawing is either hot or cold metal is pulled through dies that alter or reduce its cross-sectional shape to attain three-dimensional shape. So um, it's like you're forcing the metal in a mold so that it forms. Um, but when I chose this picture, I thought at first that he was trying to form a pot, but that's one product that can happen in drawing. No? For example, the pots for rice cookers are done by drawing. Okay, so that you force it into a mold. Now, forging happens when normally this is manual, although there are also machines that do forging. Hammering or pressing hot or cold metal to a desired shape. So when you're making knives or swords, so this is the process. Forming, of course, shapes metals by mechanical operations, excluding machining. So machining happens um, when you like intervene aside from bending, so you punch holes or you cut. Okay, but here in forming, you're simply like bending. So bending is much different because in forming, we're talking about like a mass production, but in bending, it's more of specific bending of some parts only. And sometimes this is manual, like what we see here. When we make the reinforcement, um, when apply reinforcement to columns and beams, so we have to bend the stirrups. So this is the process that we do. Brake forming, this is one of uh, the complicated or confusing term. So usually applied to plates or metal sheets. It's a process of successive pressing to achieve specific shapes. Okay, so it's like you're also bending, but we're bending sheets of metal, and then this is applied more again like mass production, unlike the bending earlier, which can be done um, in not in mass production. Now spinning, the metal has to spin around like a lathe machine while you're working on it. So because you can also carve metal, remove metal using some tools while it is spinning. So you can actually make like balusters out of metal. Embossing and coining, another term for it, is a process usually performed on flat surfaces or flat shapes to achieve textured or raised patterns. So what you see in the picture, to emboss it, so you have to like puncture it a little without going through the metal, so that it forms a particular shape. Okay, there are also machines that does embossing, but of course the process started out as manual. Now blanking is shearing, sewing, or cutting metal sheet with a punch press to achieve an outline. Now this the next processes, including blanking, are a bit confusing also because they're almost the same. But in blanking, so you have a sheet metal and then you extrude it so that you get a particular shape. And like that, the one that is removed is the product of blanking. Okay, then the one that is retained is the scrap. So, for example, in this picture, you can see some shapes which are probably some hardware. They look like well, some hinges. So after the machine went through the metal sheet, what remains are this. Okay, so the rest of the sheet is discarded. Now, perforating is putting holes on a flat sheet, but this time you're putting uh, a uniform amount of arrangement of holes in a flat sheet. So that's perforating. So although you're later on, there's what we call piercing. Also, you're putting a hole, but you're not actually putting it through all the flat sheet. So, for example, all the wire mesh that we see, which have holes, which are not weaved or woven, so they're perforated. Now, this is what I meant. No? So in piercing, we also put holes, but we do not do it like mass production, like in perforation. So in a whole sheet, maybe we only pierce a few parts. And then piercing makes use of a pointed tool, okay, to pierce the metal. So it does not make use of like a mold or a cylindrical uh, extrusion device. Um, Welding, I think everyone is familiar with welding. So it's the fusion of metals above the molten point with or without the aid of a metal filler. So we have gas welding, which is the most portable and economical and can be used on site. So the heat for fusion is provided by a torch using oxygen and acetylene gases. And then we have the welding rod, and then once it gets in contact with the um, once it gets in contact with the steel, so it creates the sparks, no, because it like melts and then it molds into to the steel. Now, in the notes I gave you, there's a lot of uh, notes about welding, some symbols and different types of welds. Those are just for information. You do not need to memorize them. Just familiarize yourself with them because you might end up working abroad or maybe in a factory, especially making ships. Mind you, even architects can end up also designing ships. No, my friend ended up one time designing all the super ferries, the interiors of the super ferries. Okay, so therefore they have to know the processes involved in constructing in boats, in ships, because they're much different from constructing outside, like a normal house construction. Okay, so let's go to finishes. Okay. Um, so first is a brightened finish. Mm, so it's produced by electrolytic brightening or dipping the metal in acid solution. So the picture shows you a vat with some acid solution. Then you dip the metal in it, and then the electrolytes sort of help uh, produce the final product, which is mostly making the metal bright. Now, buffing is done by this device, which is it's polishing using this soft fabric wheel. So it turns around, and then you put your, so it's like buffing your shoes, no? But making use of this device. Chemical finish, other than electrolyte, is not really chemical, no? But this is an example. And then directional texture finish. This time you also use spinning device, except that you're not trying to make the metal shinier, you're actually putting texture. on the metal. Okay. Etched. I think this is familiar to some of you. So you carve over the metal, or you make grooves along the metal in certain patterns. Sometimes we use it when we make the the old ways of printing, for example, makes use of etching. So you pass an ink on it, and then you press the paper, and then you have the picture. Metallic finishes are created by applying one metal to another by electrolysis. So this is when, for example, you combine some metals with another metal, like zinc or nickel. Galvanizing is another process, although there's also the same process, um, but more particular in zinc. Um, the application of zinc. Now, the rest of the metals combined can be in the metallic finishes. Pattern finish, mechanically produced, are available in various textures and designs. So it's like what you see here in the picture. So it's like the one earlier, directional finish, except that here you're not using a like a wheel, but you're using another system to create a pattern. Now, applied coatings, I think this is not yet the last. When we put, there are many, in your notes, there are many possible chemicals that can be used as coating for metals. And sometimes we call them powder coating. In a lot of furniture, especially for exports, they color, instead of painting the metal, say it's a chair or a table, metal chair, they powder coat it. So it's sturdier actually, because the metal, the coating sticks to the metal chemically. It's different from paint, although you can also use paint on metal, but then the tendency for paint is that sometimes it can also be removed even by hand. No, it does not really stick too well on the metal, and then the adhesion is uh, not chemical. So it's like just it's like you're just putting glue on the paint and the steel, and then you can still remove it. So powder coating is advisable, especially for mass-produced items like steel furniture. Now, metal sections, you have this in the notes of Architect Behik, but you need to be very familiar with these sections because you might end up talking to engineers and then them mentioning about this, or you may be wanting to mention that this is what you want. So this is how it's called. No? Universal beam is like the eye, but the narrow eye, and universal column is like a wider eye. So the horizontal parts are called the flange. So structural T has only one flange, like that: angle, joist, and channel. So you have to know the difference between a joist and a universal beam, okay? Because they almost look alike, except for some parts which are curved in joist. Now, in cold rolled section, this is especially true for aluminum. We have the plain C-section, lip C-section. We find this applied to metal studs and metal purlins, and some others like zeta section, for example, can be used for frames in windows and doors. Even Z section, I sort of remember. Then we also have curved steel sections. although I'm not too familiar with the application. And some metal products. So in construction, at least, we have sheet pilings. So what you see here in the picture are what we call, um, what's it called? It's a deck, no? It's it's a mold for decks. So you have them aligned like this, and then you pour cement over it, and then you can remove it or it can stay. So depending on the design. So it's for steel decking. Of course, pipes. You have been mentioning pipes earlier. When you reach your, I don't know whether you have already your plumbing. You will be discussing different types of pipes and different materials and different applications. So at least you're familiar already with steel materials for pipes, because there are also plastic pipes. Reinforcement steel, we also tackle this. So these are products. And welded wire fabric, which is getting more popular lately as alternate for the conventional construction in looking for lightweight construction, lightweight wall construction. Um, Steel wires, nuts and bolts, and all types of hardwares made of uh, steel. And then steel strapping, like all the sections that we saw earlier. Okay, so that's it for metals or ferrous and non-ferrous materials. So, well, before we end, I wanted to tell you about the quiz which will follow this lecture. Okay, so after this, I will publish the quiz, which will be about blocks and block works and also glass and glazing. But what I want to emphasize is that you should answer with your laptop or desktop computer. You cannot answer this quiz with a tablet or cell phone. It requires a mouse. So because there's one item which is not multiple choice, but you have to arrange all the text in particular order. So we have to drag and drop them. And well, when I was looking at YouTube on how to do it, so at least they say that this is not something you can do using only your fingers for the tablets and the, the phone. Okay, because there's only one trial. So if you start using your tablet but you end up there, you cannot stop and then do it again. Okay, you have to continue. So you might as well just skip that. So you lose like 6 points. Okay. And then the next announcement is about your midterm exam, which will be next week. So we will have that exam on Friday. Um, I wanted to meet with you still on a Monday or maybe Wednesday, one more, for a uh, special lecture. Because when I went over all the topics given by Architect Behik, I noticed that it should include something which is important, which is not actually material, but which should have been the foundation before discussing materials. So, um, but it depends. I'll post an announcement if I plan to push through with that plan. If otherwise, we will not meet anymore except we will not even meet during the exam. I'll just post the exam on Friday. So the exam will cover everything from the start, except that it's more of the most recent. I think most of them are from this lecture, and then a few from the old ones. Okay, so it should be easy, like all the rest of the quizzes. Okay. So I guess that's it. Uh, well, I noticed someone is recording because I actually forgot to record. So whoever gets the recording, please send to me. Okay. Uh, I guess that's it for now, unless you have questions. In any case, you can still send me a message or email me for questions. Okay, so goodbye for now and have a happy weekend.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Bye,
sir.
sir.